right, so we're going to continue with day 4. We're talking about transformations of e to the x, okay? So right here, we're looking at two quality questions, okay? These are big topic questions. First of all, what are some applications of e? And then the second question is, which base on an exponential function gives a graph most familiar to y is equal to e to the x, okay? All right, so we're going to start with this enrichment worksheet 7-3, and the key is attached right here. Think of these blue hyperlinks almost like if you wanted to print off at home blank notes. Here they are. If you wanted to print off the keys, you're more than welcome to. I would highly suggest printing them off blank and then kind of following the video and entering them as you would in class. And then you can always double check with the key in case you missed something or rewind the video. Okay, and then we'll end with looking at an activity on Desmos that kind of gives you practice with like conceptual understanding of transformations. Okay, so enrichment, compound interest, and the key concepts, I already have those open right here. And then here at the very end, you will see the transformations of that exponential function. Okay, so let's go ahead and begin first by looking at the enrichment 7-3. All right, so the enrichment 7-3 is talking about attributes and transformations of f of x is equal to e to the x, okay? So it says you invest $1, just $1 into a bank. Oops, let me go ahead and highlight that as I go. At First Bank of Algebra that pays an annual interest rate of 100%. Okay, so you invest $1 and it pays quite a bit. I mean, 100% is a lot as far as a return is concerned. Okay, so let's make this just a little bit smaller. We'll do that again for the other color. And then let's go back. Okay, so again, $1 is what we start off with, and it is at a rate of 100%. So if the interest rate is compounded annually, okay, that means you're hit with interest, okay? When it's compounded, it's basically saying you're hit with interest. In this case, annually means one time per year. If you were hit semi-annually, it would be 2 times a year, 2 times that year. If you were hit monthly, it would be 12 times, okay? So biannually, or semi-annually. So biannual or semi-annually, it's saying 2 times. Okay, so I'll just put 2 times like that. So 2 times per year, this is 1 time. So I'll just put 1x. Let me move that over just a little bit. So 1 time is annually. Biannually or semi-annually is 2 times. And then like monthly, that means you're going to be hit, again, hit, quote unquote, with interest 12 times. And if it was daily, it'd be 365 times, so on and so forth. Okay, so it's all in a matter of, it's talking about in a time span of 1 year. Okay. So it says you will earn $1 in interest and have $2 in the account at the end of the year. So you're making it increase by 100%. Okay. And the way we can see that is this original $1. Okay. When I multiply $1 by this interest rate of 100%. Okay. That's the same as 1 times, and we've talked about this in previous videos, the percent is going to turn into a decimal. So it'd be 1 times 1.00. Well, this is just 1. So, and this 1 signifies the interest, okay, earned. This is the extra stuff. This is the money in your pocket, okay? So if this is extra, and we were to add it back to the original $1 that we started with here and here, then it will show that it becomes $2. Okay, so this extra in green, this extra dollar that it became, That's this one. It says you will earn $1 in interest. That's the interest earned, okay? So we'll say ED, interest earned. And then 1 plus 1 is obviously going to give you a total of $2 at the end of the year. Okay, so you start with 1, and that was the red one. You increased by 1, which is that increased earned or interest earned, and then it resulted in the $2 that you had at the end of that first year. Okay, so in general, if a principal P is invested, okay, so P, remember from previous videos, this is where you start. This is your initial value. This is where you start. It almost feels like a y-intercept with lines, if you will. The y equals mx plus b. We would always tell you that b is the starting value or where you start. That's what this interpretation for p is talking about with exponential functions. So p is invested at an annual interest rate of r. So your interest rate is however much percent it is, it goes right there in the equation. And it's compounded in times per year. So that would be here and up there. So again, that n is over here that I was talking about from before. If you're hit with interest just one time a year, well, then you're going to put 1 where n is at. If you were hit semi-annually with interest or biannually, well, then you would use the number 2 and you would put a 2 where n is at in that equation. Okay, and likewise, daily would be 365, or even monthly, you would plug in the 12 there for n and the 12 there for n. Okay, so that's how you handle in this equation, okay? And then, of course, t is the amount in years. The default is always years. So you have the interest rate, you have the number of times per year, as far as that it's compounded, and then t is the amount of time in years, and then p is your starting initial value. Okay, where do you start? How much money did you invest that you started off with? And of course, with all this calculation, we're looking at it's going to come from an origin or a starting amount of 100%. Remember, you're always going to start with this 100% interpretation. Again, this is from former videos as far as talking about starting at that 1.00. Okay, and yes, we didn't put the 0.00, we just went ahead and just put this one right there to start off. That is our compound interest formula. Okay, so compound interest formula we will be using quite a bit, and when we're talking about that, we're talking specifically about this equation. And last but not least, this a value is essentially what is the amount that it would be. And in our example, our a value, let me go ahead and highlight it as we go. I could highlight this as red was where we started. That would be P, okay? The $1 that we earned in interest would be green. That's what you got afterwards. But then the total that you get as far as this $2 that you have at the end of the year, that would be the A over here, okay? All right, so that's how you do the interpretation of compound interest with this equation here. All right, so let's go ahead and move on. And it says use this formula to compare the values in the account for different compounding periods. Okay, so guys, this is heavy on calculator usage in this unit. So I'm going to definitely rely on that a lot in this problem here. We just have to understand what is the amount of times, and this is the n value. How many times are we hit with interest? Okay, so that's hit with interest in the time of 1 year span. Okay, so we'll say time in 1 year. Okay, so there we go. Quarterly is going to be 4 times a year. Monthly will be 12 times a year. Weekly is 52 weeks. Daily is 365. And then hourly is 365 times 24 because there's 24 hours in a day. And then by the minute, it's basically going to be 365 times 24 because that's how many days, or sorry, how many hours. And then how many minutes are there in each hour? There's going to be 60. And then by the second, you're simply going to multiply 1 more 60. Okay, so it's just dimensional analysis by looking at how many units are in each, or how many subunits are in each unit. Like 1 hour has 60 minutes that I'm writing right now, and at the very end, you have 60 seconds per each minute. Okay, so let's go ahead and go to our equation and start building the equation by saying the amount in years in the account after, it doesn't say the amount of interest that was accrued. It says what's the total new amount, if you will, the new amount after 1 year. And that new amount, that is this variable here. That is what the new amount is talking about, okay? The total new amount after 1 year, all highlighted in green. Okay, so let's go ahead and write this out. So we know we started with $1, so I'll start that with red. And then we know this will always start at 100%, so this is going to be 1 plus, and then the interest rate in this one was 100% that we saw way up there. So this R value, okay, let me highlight that. This R value is always going to be written in decimal form. Okay, so it's going to be a decimal that represents the interest rate. So 100%, we're simply going to move the decimal 2 to the left, and this 100% becomes 1.00 as a decimal. So we'll put 1.00, and it's over how many times did we get hit with interest this particular year. Okay, so it's going to be over. Quarterly means 4 times out of that year, so I'm going to put 4, and it's raised to the power of 4 because that's where my n goes. There's 2 n's here and here, and then it's only 1 year, so I'm going to multiply this by 1. Okay, and if you wanted to put it simplified without all these 4 times 1 or 1.00, however you want to, that's fine. Just please be careful that you do not add this numerator and this one first, but that in fact you do keep them separate, because this mathematically is what you should be handling first. Okay, so real quick off to the side, I want to make sure that you understand what I just said. 1 plus 1.00 over 4 is not the same as if you were to put 2.00 over 4, okay? Don't think that you can add these two numbers and get this numerator. That's not how PEMDAS works, okay? So if you are struggling with that, it's because multiplication and division come before addition, okay? So I would keep it like this, or technically what it's equal to, just so that you can see and understand this mistake that we're trying to avoid you doing. It's technically equivalent. So it's not equivalent to what I said before, but it is equivalent. It's the same as 4 over 4, okay? So because 4 over 4 is a form of 1, which is right here. Okay, so if that confuses you and you don't want to do 4 over 4, just make sure that you put this into the calculator as such and don't put 2.00 over 4, okay? But this is what's going on. And those of you who are understanding it, it is basically the numerators adding together with your common denominator of 4, so that it's 4 plus 1 is 5.00 over that common denominator of 4. Let me highlight the common denominator in blue. And that's just adding and subtracting fractions, okay? So if you struggled with that there just a little bit right there, go ahead and keep it this notation as you input it into the calculator. All right, so let's go ahead and enter into the calculator what we just did. We started at 1, we multiplied with our 100% that we're starting with, plus you could do control divide to get this, or just a little review, you can also press this key next to 9 to get that nice pretty little fraction. So that we have 1.00 over 4 because it was quarterly, and it's raised to the power of 4 times 1. And there's my answer. Okay, so the interest earned after one or during the first year is different. Okay, this right here that we just saw is the amount of money that's in there after 1 year. So let me come over here on my notes, I'm going to reduce this a little bit in size and move it over. All right, so let me fix this. And this was 4, because that was n, and 4 times 1. This all equaled this back here that was 2.44. So because it's money, I'm going to round to the nearest penny, 2.44, okay? So now monthly is when n is 12. So it's basically everything is the same except for n. N is the only number that is different, okay? And again, let me highlight it in orange. N is way up here as far as in the power and in the denominator. So what used to be 4 and 4, I'm now going to turn into a 12 because we're talking about monthly compound interest. So with the calculator, let me go up and press enter to copy this. And I'm simply just going to change this to 12 and this other one to 12. And there's my answer. Okay, so let me write this down before I change the screen. It will give me $2.61, it looks like. And it came from let me color coordinate this so you understand. 1 times 1 plus something over something. And our interest rate remains the 1.00 because it was 100%. And this time it was 12 because that's how many times we multiplied or we applied the interest. Okay, that's how many times you were hit with interest. Raised to the power of 12 times 1 because we're talking about just 1 year. That's why that 1 is there. Okay, and we get $2.61. Now I'm going to just quickly now input all these values just to get the other piece. Okay, so the only things that are changing are this 12 per se. This 4, which is now a 12, which is going to turn into a 52, which is going to turn into a 365, so on and so forth, okay? So look what I'm going to do with the calculator. I'm going to get very clever with the calculator, and I'm simply going to say, this is my equation that keeps recurring, and I'm going to make this my variable because it's changing, okay? So I'm going to change this to still 1.00. This is x. And I'm now going to save this by pressing Control Store, and I'm going to save it as f of x, okay? And this was in prior videos too, as far as a fast way to store a function that you're going to use over and over and over again, okay? So let's check this real quick. What's f of 1? Well, it's the answer, f of 1 is after 1 year, what would it be? Okay, no, actually, this right here is just saying if I got hit with interest 1 time a year. So if I'm trying to get this answer of $2.44, I need to say, okay, because this is all in 1 year's time, I need to say if I got hit with interest 4 times, okay, which was that quarterly thing. Let me go back here. It was this quarterly 4 times per year. Then I would have an answer of 244, 14065. It's exactly the same as this one. And if I got hit with interest 12 times a year, so monthly, it would be 261,3035. So 261,3035. So $2.61. So see, we just created this stored equation that'll now spit out the answers. And yes, you can use the table as well, and some of us know how to use that. But this is a faster way, I believe, that can get you the same answers. Let's now go to weekly, daily, hourly, and so on and so forth. So we're going to say weekly is 52. Okay. Okay. And then we have daily, which is 365. So that's f of 365. Oops, lowercase f of 365. And then we have hourly. So again, we went 24, because there's 24 hours in a day, times 365. So we go 365 times 24. See, and then over here we have times 60. So we can come up and press enter to copy it, and then do times 60. And then we can even go up and copy it and times 60 more for those seconds. Okay. So these are our answers at f of 52, and so on and so forth. So let me go ahead and write these in before I switch my screen. Okay, we have $2.69. We have $2.71. Then we have $2.72. I'm going to round up, and you can round up or truncate. That means just write two numbers and that's it, whether it rounds or not. I'm a rounding kind of person, so I wouldn't leave that as 2.71. I would round it to 2.72. Either one is correct. And then we would have 2.72 for the by minute. And then last but not least, at the very end, we still have 2.72. Okay, but you see that it's getting closer and closer. It keeps like 2.71812, 1827, 1828, and you guessed it. What this is actually doing is approaching Euler's number, okay, of 2.71828, 1828, 459045, and so on and so forth. That irrational number that we spoke about in the previous video. Okay, so now, if I now go to see how much interest was actually earned, okay, what's the extra stuff? All I need to do is find out this total minus what I started with. Okay, so this total that says $2.44 is what I had after the end of the year, after that first year ended. All I'm going to do is 244, right? And I'm going to subtract the $1 that I started off with. So how much money did I make? This is how much I made. I made $1.44. Okay? And then we just keep doing that. 261 minus 1, because again, we're starting with $1. I made $1.61. Subtracting 1, I made $1.69. I made $1.71. I made $1.72, $1.72, and $1.72. Okay, and I'm rounding to two decimal places only because this is for money. Okay, and if I were to write out more, yes, it's that number, Euler's number, as far as 2.71828 that I talked about. But just because of the sake of money, I know the notes show more decimal numbers as far as the key is concerned, but this is just how much I've earned after the first year. Okay, so the amount of interest grows close to, as far as interest alone, 1.71828. Okay, so 1.71828. This is what the interest grows close to. Okay, or the number E. And the number E is going to be over here because it is including, so this includes the starting amount. That starting amount of $1 that you walked into that bank with. So starting amount. And this right here is E. So 2.71828 and so on and so forth. Okay. This is E. So as the frequency of compounding increases, in other words, as you get hit and hit and hit and hit with more times that you're getting hit with interest in 1 year, the more money the interest will earn, okay? The more it will earn. So obviously, look at this. 144 is just getting hit 4 times a year. And getting hit one time we saw was only $1. But if I got hit by the second, it'd be $1.72. So obviously, we don't want banks to charge us every second. We want them to charge us less. But if we're earning money like on an investment, we want it to apply as much as it can so that we can make the most money that we can. So look at the pattern of the numbers in your table. What amount do you think would be the account at the end of the year if interest were compounded annually? And yes, for this one at the end of the year, compounded annually, the amount would be $2.72. Okay. All right.